Assalamualaikum warahmatullahi wabarakatuh and very good morning. So today is our lecture 3 on Optimum design with Matlab. And the notes are from chapter 2 of our textbooks Aurora. Okay, so the learning objective for this chapter is upon completion of this chapter, you will be able to use the capabilities of the optimization toolbox in Matlab to solve both unconstrained and constrained optimizations. So if I can recall what we did, do you still remember what we did for our lecture 1 and lecture 2 class? Can someone recall and share
Yeah.
what is chapter 1 all about?
Chapter 1 was about an overview about the
Actually,
introduction about the optimization design. Yeah,
Okay,
yeah.
so basically the process, right? What is optimization all about? The
find
introductions. Okay,
the
so just a very brief introduction to a design optimization. Introduction to design optimization. What about chapter 2?
It was about the steps that we should take in order to get the formulation.
Yeah, okay, the 5 steps. We start with a description of the problems. So whatever situation that you have, you must able to formulate, to describe the problems or the situations. And then the second step is getting the data. Okay,
Mhm.
the data, the variables, the constraint and so forth. And then define the design variables. What is actually we want to design? Either we want to design the length, the width, or the R, for example, like the column, the R, what is the dimension of the radius of the column and so forth. And then we look at the design criteria, and then we formulate the optimization criteria is basically our objective function. Okay, and then we formulate the constraint. That is regarding chapter 2, and then we try to understand the concept by looking at several examples. Okay, and then what about chapter 3?
So graphically solve the problem,
Yeah,
linear
graphically.
problem. Yeah,
Yeah, graphical, right? We
yeah.
try to use graphical method in using all the 5 steps. Okay, getting everything together and solve using graphical. What about chapter 4 finally?
To understand the global minima, global maxima.
Yeah,
Well,
okay, the local and the local and the global minimum, the concept. And then I think we try to solve again using the graphical and looking at the constraint, equality constraint, and then the inequality
for the
constraint and so
Lagrange
forth. We
multiplier.
continue the concept of chapter 3. Okay, so today having fully understand with the concept of engineering design optimization, either through concept of getting the formulation and follow up with solving it graphically. Uh, the chapter 7 is using now, we will use, instead of using graphical method, we try to use the functions that are built in MATLAB. Okay, so MATLAB help us to solve these optimization problems that we have been looking through previously, using some of the toolbox that they have in their uh, software. Okay, so that's why the learning objective for this chapter, able we you are able to use the optimization toolbox in MATLAB to solve both unconstrained and constrained optimization problem. We look into two, unconstrained and constrained optimization slowly. Okay. So the outline for chapter 7, basically, we look into the function optimization. We look at the optimization toolbox, and we look some routines and algorithms available. So most of the optimization, the example for the standard, the default toolbox for the optimization is concentrating on minimization. Okay, so what happens if we have problem, if you want to solve the maximization problems? So we will look into it, but mostly the examples started or the functions are for minimization. So we start with unconstrained, and then follow up with the constraint, and then we look at the algorithm. In Matlab, we can either build the algorithm using script files, or we can test using our command window. For example, for a very simple command, just to get the optimization from the optimization function, maybe it involves only one or two line. So we don't have to use the script. So we can also try to check, or if you want to check our algorithm, we can use the command line. And also in optimization, there are two ways. Either we build in the MATLAB files using the script, and we save it as script files. Or there are, if you look at MATLAB later on, when we go into the problems, there is applications, they call it optimizations tools thing. So we also look into that as well. Okay. Okay, so optimization is based on finding, in this example, finding the minimum point of a given functions. Let's say this is our function. So described by a line, the blue line. So fx equal to some equations. Okay, and then we want to find the minimum point. Okay, so back to your calculus basic class. Minimum, how to get the minimum point? Remember?
Uh, differentiate,
Yeah.
drive the function.
Yeah. The
Yeah,
derivative is equal to
zero.
0. Okay.
Zero.
df over dx equal to 0. Therefore, we have this minimum point. Okay. So, introduction to optimization toolbox. MATLAB is a high-level programming language for computation, data analysis, and graphics. So, by this, you're already familiar with MATLABs. The statements are usually in form variable or expressions. It's very easy for you to start with MATLAB. Okay, so variables are scala, arrays, or matrices. Okay, so we look into it before. So we have arithmetics, we have vector and matrix. Okay, so optimization is important in modeling, simulation, and control. I think uh, everything it can be applied in many field, either in engineering, mechanical, electrical, civil, chemical, industrial, and also for uh, economics, financial, and so forth. Okay, so two examples in MATLAB function regarding optimization, uh, F min B and D. Okay, so minimum, find minimum of single variable function on fixed interval. That is what it means with F min B and D. And then another one is F min search. This function is similar except it handles function of many variables. So one is for single variable, for example, fx equal to function with x squared plus 3x plus 2, for example. And then f means search usually fxy or fx1, x2, x3, something. So other functions are as shown in table. So there are actually a lot of um, functions, optimization functions in MATLAB. So you can explore later on. So just like what we discussed before, F min B and D is for one variable minimization in fixed interval. So we have the upper limit and the lower limit. and we want to find f, for example, just like the graph that I shared you before. So let's say we have an interval between minus 20 to 20. So this is a function. We want to uh, find what is the minimum point here, as well as what is the value at that minimum point. So in these particular examples, we have about minus 5. The x is minus 5, and the function equal to 0. The f is equal to 0, the value. Okay. So there is also f min UNC, f min search, and f min con. So I think we will look into f min search and con. Okay. And then one is for unconstrained, so meaning that you don't have constraint that we look into before, right? Okay, so just simply a function like the graph that I showed you before. So simply find x where fx equal to minimum point. So no constraint. So we can use f min unc, f min search, f min con. I think f min con is for constraint. Sorry, f min con supposed to be down. Okay, so for constraint minimization, just like what we did in chapter 2, chapter 3, we have constraint. Okay, so in either equality constraint or unequality constraint. So we have constraint, we have to find x to minimize our function subject to, so these are the constraints. Usually, previously, if you can still remember, we did not the constraint with g, to not to be confused with our function f, or sometimes h. And then we have the what we call the lower and upper limit of the x. So otherwise, sometimes we cannot find if it is infinity. Yeah? So there's another optimization functions. They call it linproc. This is for linear programming. So we're going to look at one example on that. And then another one is quadratic. And I'm not going to touch details on up until quadratic. So maybe we go up until linear programming. Okay. So explanation sometimes this is when you run the optimization functions just now, f min ULC, f min BND, okay, f min corn, linproc something. So they will, if you run it on either on the script file or on the command window, we will have output like X fund value, exit flag, and output. So these are the description for that. Okay, so we look through this later on. Okay, for the value of objective function, and then exit flag. If exit flag is positive, then optimization routine converge. If exit flag is 0, the maximum number of function events was reached. If exit flag is negative, then the optimization did not converge. Okay, so this is regarding output. Okay, so how do we use or uh, apply our um, functions, optimization function? So the syntax is to invoke optimization function. So this is, for example, let's say our function is f min. Okay, so these here are the output. Okay, and these here are the syntax. Left quantities written by the functions, right the function itself. So in this case, let's say the function's name is f min x. So we have to start with the name of the objective function and so forth. So each of the optimization function that I described earlier in the blue table, it will comes with syntax. So sometimes we don't remember what is the syntax. You will have, I think when I tried Matlab 2020, sometimes when we start um, name the functions, they will appear, kan? Okay? Or otherwise, you can always refer to Matlab's search, eh? help or search website. Okay. Okay, so that is regarding syntax to invoke, to use the optimization functions. Okay, so implementing optimization toolbox, most of these optimization routines require the definition of an M file containing the function. So let's say we want to have f equal to x squared plus 3x, for example. That is our equation. So we need to put these functions into the functions, okay, into a function file. And then later we will invoke the optimization function to to solve our optimization problem. Maximize. Okay, just now I said most of the optimization tools in the Matlab is for minimization. So what if we want to, for example, maximize profit? Okay, so basically using the routines, what we have to do is we have to negative to inverse the values. So to put negative inside our equations. Usually we start with our equations. We put a negative value to the equations, and then later on we reverse it back. So optimization options pass to the routine, change optimization parameters. Default optimization parameters can be changed through an option structures. We look into that later. So far, okay, class? Okay? Okay.
Oh yeah, okay.
Okay, so scripts and functions in MATLAB. Scripts are the simplest type of, seems that something missing. They store commands exactly as you would type them at the command line. Sometimes we can write, it's involve only one or two line in the command line, but sometimes we want to have more flexibility because our functions keep on changing, or our information keep on adding. Yeah, so it will be easier if you can write the script rather than using the command. For example, like this one, you only have, okay, 3 line. You can simply write in the command line, but sometimes your functions keep on changing. So in this case, the function is for factorial. Okay, factorial of a number n, and then they return the result f. So let's say n is 5. What is the value? So, okay. So how do we do that? No, this one. Okay. So we build in the function, and then we call it at the command line. Okay, can we start, class? Please open your MATLAB. Either have you download, or you can use online. Okay, let us use online.
Okay, okay. I already
Download, or you
downloaded. I
can
have.
online. Online, make sure that
Yeah, I have
sometimes
it
I
already.
I like to use online. Sometimes online is much for me, but then okay, it's up to you. Okay, let's say this is my MATLAB. Can you see my MATLAB online now?
Yeah, it is downloading.
What about on the screen? Can you see mine?
Uh, Half of it, yes.
Boleh kan Izzat? Nampak tak Izzat?
Nampak
Nampak eh?
better.
So let's say we
Nampak.
want to build a new function. Okay. So what is the function previously? So go back to my slide. Okay, so just copy here whatever that I written here. So function f equal factorial of n. So what will it do? F equal prod 1 until n. Okay, so I save my function. So what shall the name of my function? Fact lah. Okay. Okay. Okay, hopefully it works. And now let me put my x equal to 5. So I need everyone to do it, okay? So if I got syntax, you can troubleshoot me. Okay. Y equal, so we call our function FAC in our x. Okay, everyone. So now you managed to build in one function. So okay, class? Boleh?
Yeah, it's okay.
Okay, so everyone try.
Mhm.
Okay, so this is the script and
Yes.
function before
Yes.
we go
Okay.
through the optimization. So
Yes.
scripts are the simplest because sometimes our function we involve a lot of equations. For example, the one that I give you my students examples. So it requires a lot of information. The A, the first one that I shared with you is on microchannel heat sink. The width, the length, the distance between the wall, okay, and then the material, because sometimes when we have the equations, the resistance, because in that example, we want to determine the I think minimum thermal resistance. So the R will involve a lot of data, a lot of information we want to put inside our function. This one only 3 line, but there's sometimes functions. Uh, function is the most important things. For example, like whatever that your project is, so being able to describe the mathematics of it is the most important thing. For example, one of the example in my student case, like this one, the uh, thermal resistance, the microchannel heat sink. And then I also shared with you Atika's project, right? The thermoacoustic. Did I? Class? Thermoacoustic, thermoacoustic where from sound it can
Yes. Yes.
um, provide energy as well. So the the important
Yeah,
part,
right.
the
I
important
do
part
remember it.
in your research work is getting this mathematical description of your study area, whatever the study area that you involve in, the thermoacoustic refrigeration, the microchannel heat sink, or in supply chain. One of my students in the supply chain, he has to derive the mathematical equations involve the supply and the demand and so forth. So the most important, once you have this mathematical description, you can put into your functions and you can use the optimization
Mm.
toolbox available in Matlab. Okay, during my time, I am the one who has to write the equation for the optimization. For example, I'm using a modified genetic algorithm. I am the one who has to write the programming for genetic algorithm, the modified genetic algorithm, and then load my data, load and so forth, and we use that. But now life is much simpler for you. You have this optimization toolbox. You just simply use it. But the tricky part is to have uh, your problems or your research being able to describe in the mathematical equation so that you can put inside your function. Okay. Okay, so create function. Another option for storing function is to include them at the end of a script. For example, this like previously we have particularly our functions, okay, and then we call it at the command line. Okay, so this is another way. We don't want to have it separate, so I want it to be inside my function. So let for example like this one, it has two functions. Perm, I can't remember what is perm for. And then another function is factorial. So can we try this one as well? What will the answer give us? Plus, just for you to get familiar with the functions.
In MATLAB, the MATLAB asked me about what is the value of n. Uh,
This one,
yeah,
the value of n.
yeah, because
This one, it doesn't ask me anything
I don't
because.
know.
So you have it as function?
I got an error.
You have it as function?
there I put my function and it's already, but when I click run, stop. I don't know.
Uh, please make sure that you have here at the command line. This is only function. Now the fact n is from x, you have to define it somewhere. This is when we have script and function
Hmm?
separate. The next example will be script and function in one file. Have you tried with the command window, giving the value of n?
Mm.
Is that boleh? You want to
Yeah.
share?
Yeah, yeah. Actually, I'm trying to.
You have to call it here at the.
Oh yeah, now
Now
it
it
works.
works, right? Because you have to
Yeah,
call
I
it in
put
the command
double
window.
semicolon. Sorry,
Because
when I added the y.
yeah, because
Yeah,
I have functions and the command
yeah,
is the
right.
separate file. The second one will
Yeah,
be
yeah.
everything include.
No, I wrote, but I put double semicolon at that side, so this.
Oh,
Yeah.
okay, I see. Is that okay? Is that boleh kena cuba sebab
Okay,
lepas ni
it's
I want you to do some
Hmm.
example.
fine.
Okay.
Okay, let
Okay.
us look at the second one. Okay, can you try this one? I can't remember what is the function perm for. Perm and r factorial times factorial minus 1. Permutation. Is it permutation? It's permutation. Okay, never mind. Can you try this one? So I just copy
Hmm.
the function. Let's say I name it as. Okay. So we have, can you see here? We have two function in the script file. Okay. So we want to do permutation of 3 and 2, and also factorial, factorial n. You can also run section. Could start with n, and we want to find what is z. Okay, permutation. So the answer should be 6. What is permutation? This one, factorial times factorial n minus r. Okay, so this is another way to have your functions built in your script file. Okay. Okay. Now, this some more on the functions. Because we remember previously I said that we have to have our function for whatever problems that we look into in order to use to invoke the optimization toolbox. Okay, so more on function. Basically, when we want to have function file, so function is, we start with the functions, and this side, the left hand side, are all the outputs that we want it to be. Okay. For example, function ms. So we want to find what is the sum and the square root. So at the end, we should have values of this one. Okay, these are the outputs that will be displayed in our command window. And then equal, this is the name of our function that we're going to build. And the right hand sides are all the inputs. Okay, so example function ms, where m is the output. M in this case we have two outputs, sum and square root, and x is our inputs. Okay, let's say we have inputs of this one in a matrix form. Okay, and then we use this functions, we should give this value. So I don't know why I put it comma. Can you try this one? Getting familiar with function. I don't know whether this is the correct way. Either it's comma or semicolon. Can you please check for me this one? Not sure whether comma or never mind. Let us try. Copy that. Command C. Cannot. Okay, I have to put those too many. Command paste. Okay, so save. Suppose the name is as stat. Save as stat. Otherwise, we cannot call that. So the name of the file should be same as the function's name, stat. Make sure that. Okay, so now I put in the command window. Let's say I want to find this value. Command. Oops. Okay. Fill up. Command C. Maybe. Okay. So my X is in the. Let me look at what is the values. Okay, so the values in a row, on a row column. So this is the value. So I want to find the average and standard deviation. So M for this one. So I call the, so my output is average AVG. Then it's supposed to be this one, M and S. Okay, average, I just put it full because the average and standard deviation. So these are my outputs. And then I'm calling the function stat, and my X is in the um, matrix form, a row, one row. So it's described as values. Okay, so these are the output average of these values. Okay, if you look at the equation, M is sum divided by the number n. Okay, and then the standard deviation, this is the equation, so we have that. So this is the standard or the syntax for um, writing up functions, because I need you to write functions in the next example. Okay, so far okay?
Okay.
Okay, so I describe on the functions, and then how to either separate functions or having it in a script file, and then the syntax for functions. Okay, so if everything's okay, I proceed with optimization. Okay, now that we understand the concept of functions, okay, we want to use our optimizations function. But we start with unconstrained. So we don't have constraint just like in chapter 3. Yeah. So just a simple equation. So we want to find the minimum values and what is the f for that minimum values. Okay. So we start with using f min b and d function for single variable. Uh, it can also use for multivariable unconstrained, but it is for unconstrained. Okay, and the syntax is x equal f min function. So this is what is your equations. Okay, so x1, x2 are the limits. And then options, sometimes there is a list of options. So let us look at Matlab again and type help. Look at help f min b and d, f min b and d. So looking at the syntax. So this is actually the syntax for f min b and d. Okay, you can either have x equal to f. This is the simplest one. X equal to f min b and d. Uh, Having the interval. Or if you have want to have more options, you can have options. Options such as optim set. Okay, so you just can look at that. Or if you want to add more, you want also is rather than x, you want also the value. So the value, make sure that you have it described in your function. Okay, x value meaning that what is your y. Okay, so make sure your y will be described in your function. Okay, and then sometimes you put exit flag. What is that? Does that mean? So these are the descriptions. So 0 means iterations, maximum number of iterations reached. Okay, if it is 1 is converge, minus it does not converge. So these are the examples. Okay. Okay, so the simplest one is x, the output, the function, our equation, the limit. Okay, so this is actually the first graph that I showed you before. It is an equation. So the equation is y equal to 2x squared plus 20x minus 22. So now, uh, how do we find the minimum of this graph, okay, between minus 20 to 20? So using the direct search method, how do we usually do? If you learn calculus class,
Drive the function first.
you do the derivatives, or if you
Yeah.
direct search, you try
Yeah.
one by one. This is what happened if you do the direct search. Yeah.
Mm.
So you have your x between 20 to minus 0, 20 from minus 20 to 20, and the increment is 0.1. And then you put your equation, and then you ask this one to plot. Just is basically to get the idea of the graph. And then just grade for decoration. And then for I equal to 1, let's say I start my I from 1 until between the limit. So it will calculate until we find the minimum point. Meaning that is search one by one, the iterations. So until it reach, and then it will give you the y and the x. So this is an ordinary, simple way of doing your minimization without using the toolbox. Okay, so let us try with these programs and write how, what is the output class. So I leave it there. You copy in your Matlab. Make sure you do not, you include the dot for every multiplication. The dot here. 2 dot star x dot for power 2. Okay, so far?
Yeah, I got the shape.
We got the shape. Okay. What about the x and the y?
Let me see.
It's supposed to have here. The x will be -5. The y will be 72. I don't know. 72 is it? Zero kan? Hmm. Salah ni. Why 72?
I don't know. Actually, I got, I don't know, X. Mm, so it's 0, and
Y is 0 or 72?
I don't know. Graphically, it should be like,
Okay, never mind. I try copy. Try that one.
yeah, on line 8, just add double equal. I think
Equal.
and on line 8,
Line 8.
yeah, I double equal to get the equality. Yeah,
Double equal.
yeah,
Okay.
yeah, yeah.
Something
Now
like
it
this. Okay,
works.
what else?
I think that's it work now. Just yeah, yeah,
378?
yeah. Me as well. I got this. I don't know.
378.
Yeah,
378.
yeah. I got this.
But graphically, it is not 378.
I think this
This
is
is
the
minus
incremental
20.
value. Yeah,
Huh?
I
It
think.
doesn't find the minimum value, right?
Yeah, this one just like for a graph, just to graph, to graphically do it. I mean, I guess.
Okay, so never mind. We try it again. Minus 20. Okay. Okay, let me take a look at that. Why does it reach the minimum point?
I think
I think this one is plus. Let me try. Supposed to be plus. What might try? Yeah. How I got it? Supposed to be plus.
a plus. Okay.
So yeah, y1 current y is more than, so it will keep on continue. Otherwise, it will uh, maintain the what is the maximum. Yes, this is
Yeah, I
the correct answer.
yeah, right.
So this one is supposed to be minus. So this is not zero, minus. So this is the correct answer. Okay, we
Yeah.
try to find one by one, getting the smallest number until we reach the minimum, because this is the question.
Mm-hmm.
While the current is more, is continue until it reach the less or the minimum value. Okay, so this is the way. Let me edit this one. This plus. Okay, so far
Okay.
this is the challenge having the class at home. Can you see the noise? Can you hear the noise?
No, it's okay. No.
Okay, never mind. We continue. Okay, this is solving this minimization direct search method. We try it one by one. It is okay if we have only one minimum here, but if we have another local minimum, so it will stop here. Yeah, that is
Mm.
what happened for local minimum trap in the what does it mean by trap in local minimum? Okay, so this is particularly the advantage of direct search method. Okay, now this is what happened in this equation. Traditionally, in mathematics, in calculus, this is what you do. If you have an equation, so you want to find the minimum point, you find the derivative. So when you find the derivative for this equation, it will be 4x plus 20. And then this is the answer, minus 72. Okay. So when you have the derivative, you can find what is the value of 5. Again, the value of 5 is supposed to be minus. Okay, that's why sometimes I put my notes at after class. A lot of mistake. Okay, so x will be minus 5, and put the minus 5 back to the equation. We have
Okay.
our y equal to minus 72. Okay, so now we try this with optimization functions. We start with f, min, b, and d. Okay, so how
Mm.
do we start? First, this is why the importance of having your functions. Okay, so now my function is this equation. So I name my function as my function 1 with my variable is x. So this is the output. So this is the input. This is the name of my function. So make sure you save your file, function file, the same as the name of your function. And then you want to invoke the optimization function. Either you build in another script file, or you can put everything here on the command window. Okay, so let us start. Build the function first, and then let us have two files. One is the function files, another one is the uh, optimization file. Okay, class, go back to your Matlab, two file. Salah again. Again, another mistake, my function 1.
Sorry, this is 1 and 2 in the same my file, or
1 is the function file. Let us do 2 separate file. One
okay.
is the function file. Okay, another one is the script file. And then when we want name any name, for example, optimization 1. And then when you want to run, you just run this one, the optimization. Okay, because we use the fmin bnd and call our function here.
Okay, yeah, I got
Okay,
it.
the syntax is, if you can remember the syntax, okay, it should have function. Then our output, let's say function, usually it will, when you type function, I think it will automatically change to blue color, right?
Yes.
In Matlab, it will automatically change to blue color. So what is your output?
I
You say
got
my output is,
X max, X min
uh-huh,
1.1547,
okay.
and yeah, and yeah.
Can you write on the chat? Can you write on chat?
Okay, sure.
You can either put, you can also put the, if you go back to syntax just now, syntax of function, where is just now the syntax of function? Never mind. This is your function. Huh? Okay. So first I have my function. Command. Oh, Command C. Command V. So automatically function will turn into blue color, and your name should be function 1. Okay, save as some version, it will automatically save you as the name of the function. So that's it, Y func 1. So your value, what about is that sama ke?
Tengah type lagi. Saya tak boleh copy.
Tengah type, okay. So this is your function file. Then we have another script file. Command D. I save as I already have example one, e.g. Oh, contoh, I put it in Malay. Contoh satu. Okay. So this is my function. Okay, all the equation. And then this is how I call f min b to find my function. I ask it to plot the function. Okay, let us run. Eh, you did not have the same answer?
Why?
Why?
Strange, I don't know.
Okay, make sure your function is correct. Your function is correct.
Yeah, should be. I checked, but I don't know.
You
Let me
check.
double check.
And then this is, you use f min b and d, call your function. These are the limit. Okay, the syntax, this is the limit. Lower bound, upper bound.
Just 28. Yeah, here's my mistake, I think. This one, minus 20, 20?
This is the limit. The lower minus
Yeah.
20 and the upper, remember the syntax just now?
Yeah,
Uh,
and this one. Uh,
Syntax, f min b and d. Okay, here. The syntax, yeah, x1 and x2 must be x between x1, lower bound, x2, upper bound. Okay, fun is the function, like our case, my fun one, my function one, and this one here. Okay, y, uh, y, f min b. So I need to find y, and I also want to find what is my min, x and y. So let's say x, my x, instead of I put it x, I put x min. F min b. Fun is my fun one. At. Okay. And then I run contoh satu. Should get the figure as well as the value here.
Yes, dapat tu.
Let's say I just call. If you don't want to write the program, you just call. You call your function. You use the Matlab optimization f min b and d, your function, and then your limit. This one I just some decoration here. Okay. I want to plot. Okay, Izzat boleh ke?
Yes, boleh tu.
Dapat
Ah.
Okay. So saya teruskan. I just continue. What did we do just now? This one, we stop here. Okay, now I want you to do this exercise. We have our function here. So the limit is between -3 to 3. So first you put your
equation.
function. And then you call, either you can call using command window. If you want to plot and do something about it, you can follow the step in the example one. Okay? Give you about 10 minutes. Very simple one.
Okay.
How's everyone? Using the fmin bnd.
Yeah,
Okay, everyone
yeah,
getting the
yeah.
answer?
I got the answer. Just
So what is your x and what is your f for this
uh,
point?
yeah.
So it
This,
should be supposed to be 1 point something, and then maybe negative 3, negative 4.
yeah, I got this.
Is that?
Wait ada.
So,
So I copy just now. This one? This is your answer?
yeah,
Okay. Izzat pun dapat lebih kurang macam ni? So,
Belum lagi doktor.
belum lagi.
Belum lagi. Tengah.
My function tu. Three minus 4. Nine upon 2. Common C. So the limit is between 3. Or if you don't want to put it, you can declare here also. It's okay. This one, because I want to plot. F equal to func x, and then my func 2 between minus 3 to 3. Save as. Contoh 2. Oops. Contoh. Okay. Func 2. Y line 2. Open. Plot. Why it can't plot? Sama. Eh, 401. How come? Why my number is not the same? Shh. Okay. See. Same?
Yes, that's the same. I got
Same.
same with Baki.
The same as Bakir. 1154. How come my answer is 3.7? 1.1547. But why my main is 3.76? 3.09. How come mine is something wrong with my equation, I guess. Minus 4 x. Huh. How come my answer is 3.7? It's supposed to be minus
I
3.09,
guess
eh?
maybe we don't need dot for dot. Maybe
Dot.
we don't need it.
This one,
Yeah, I think it is not necessary. I'm not sure.
here is safe. Still,
Doctor, there is my function one. You need to change it.
function 1.
Yeah.
Okay. See, no wonder. Okay. 3.7. Still 3.0792. Why?
Yeah, the same of mine. The same result now.
3072, not 92, huh? So I
Yeah.
miss here 7. Is it?
7. Yeah, yes.
Okay.
Yeah.
Okay, so everyone safe. So we continue. Okay, so okay, perfect. Okay, try another one. This is from Aurora. Okay, another example. Okay, class, try. Without looking at the answer, try. Okay, please share your answer in chat. Okay, I try again. This one function. Copy paste. But make sure this time I have to Command C, Command V. So my function 3, 2, 2 minus 4. How do we write exponential? XP
EXP.
in bracket
Yeah. Two brackets. Yeah.
X. Okay, so save as. So the value is between minus 10. 10 3. This one have I saved? Then I save. So save as. Okay, everyone got the answer? Not yet?
Oh yeah, it's coming.
Is it?
Mm, I have error at the equation.
The error? Okay. Let us debug. Okay. The answer is a wrong answer. Supposed to be 1.386. Huh. Two minus see, plus exponential e exponential x, and is it the same? How come 2.1988? Okay, so plot f. Yeah. So this is your f, right? You have the same f with me. How come so this is my function? Did I miss anything? And then this is my func3, my func2. Okay, this one. Ah, yeah, func3. This is what happened when you copy paste. Okay. Okay, this is the answer. Supposed to have this answer. Okay, class. Yes, do you have the same answer with me? 1.3863 and your y is 0.4548. Same answer? Izzat and Bakir? Hello?
Hello.
Yeah,
My
I'm trying to find. I'm just facing some difficulty.
Syntax.
Yeah, just.
my question still error. I don't know why.
Yeah, I cannot hear you. Is that
My question still error.
your equation still error? Which one? Your
Ah,
function or
yes,
your
function.
function?
But I already same with you. My question same with you. But I don't know what's the problem.
4 dot x. I think same dot or without. So you should have 2 minus 4x.
Okay. And it actually same.
Same.
But it's still
Still
error.
cannot.
Yeah.
Heran juga tu. 2 minus 4x plus exponential x. You try it at the command line. You declare x first, like what I did. I declare x.
Okay.
Ambil dulu x tadi. This one x with the semicolon. Command copy, and then I put the command line. Okay. And then try put the equation. Does it works or not? Sometimes kat sini kita ada termiss. Okay. You should get something like this for your F.
Okay.
Boleh? Is that?
Tengah try.
I got these answers. I think yeah.
The answer
I
is
think,
this one.
uh,
1.3.
yeah,
Tuan,
but
this
my Y is different. I don't know.
your Y. What is your Y? Have you?
Um,
Please make sure you change your function. If you copy and paste just like me, your
no,
function is
I
function 3.
yeah, I did change it.
Really?
Um,
Hmm.
but let me see.
So this is the answer.
Uh,
Don't know what happened. Izzat kat mana tak dapat?
Dekat equation. Sebab saya rasa yang multiply tu saya punya dia ke atas. Dia tak macam multiply doktor tu.
Dia tak macam
Yang
mana?
macam yang star tu. Yang macam star tu. Untuk
Ha?
darab. Yang
Dia
darab
kena
tu.
pakai star.
Saya pakai star tapi star saya ke atas. Tak macam doktor. Saya takut error kat situ. Sebab equation semua
Star ke
sama.
atas. Macam mana pula star ke atas? So,
Nah, tu dia
sebelum
dia
ni
jadi
star okey. What about masa function 2? Okey je star.
mas.
Copy je lah daripada function 2.
Okey, sekejap saya try.
So this is answer from Bakir.
yeah,
Okay?
I got it.
Okay? Bakir got the answer. Izzat belum lagi Izzat stuck dekat function
Sekejap. Lain sama.
Copy paste je equation daripada previous functions. Boleh Izzat?
Belum lagi tak boleh juga. Ah,
Make sure your equation is right. 2 minus 4x plus exponential x. X bracket. Then you just call.
Okey, dah dapat.
Okay, boleh? So
Boleh.
I move to the next so you can also put it like this. Let us try put it like this one. X font value.
What is this formula? Seems different, like what we've worked on.
Pardon?
What is this like? This X fun val like exit command. I don't understand.
Pardon? I cannot understand. I cannot get your question.
I mean, this one, the formula. This one for fmin bnd is different from that we've worked on.
This one, the slide right now.
Yeah, this one is quite different from that we applied.
Say
Uh, different. I mean, I don't know. So,
different. This one, the syntax. I'm using the full syntax. Okay,
Okay.
mm,
if you look at help, uh, fmin bnd, there are various ways of writing your this one. Eval is
mm,
the y.
mm,
The one that I did is one by one. Let's say I'm using my function tree, but I want to call it this way. Okay, so I
mm,
want to call it this way. Copy. I don't need the script file. I just want it
mm,
to do in at the command window. So I
mhm,
put it that way, and then okay. So I just put describe the LB. No, I put my value minus 10, and then my function is this is another way. What is the name of my function? My func tree. Okay, tree. And then what are these all val? If you look here, val is our okay. This one, So let me start. Okay,
Oh, okay.
this is another way. So it will give us the value, the fun val, and the exit flag. This is the output. Remember the when I described the syntax for function just now? Okay, the syntax for function. These are the outputs. When we want to call it, yeah, this is how we call it. Let me go straight. This one.
mm,
Okay. So many ways. You just go through this. Which one that you want to take? I
mm,
start for first one, two, three. Example one, two. I'm using only this one. Okay, our function, and then the limit. So we can also have it
mm,
like this. Okay.
mhm.
Okay.
Okay, thank you.
Okay. So this is another way how you want it to be. This one is actually the output part.
Mhm,
Okay. And then uh, in this case, the way to call the objective function is by using the what is this one called open and close. Okay.
uh, parentheses.
Previously what we did, we put the call at another way.
Okay.
Okay.
That.
Okay.
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 Okay. Any question? Okay. If you don't have any question, we start with another example. Rosenbrock's banana function. Okay. So this one we have two x and y, two variables. Okay. Previously, the first three example is only single variable, and the optimization function that we use is fmin b and d. Okay. Now we have two x and y, and this you want to close. So we have this function with two variables x and y. This is our equation. So this function is a famous test case for optimization software. Two variables x and y. Plot the function and find the minimum point and value for this function. Okay, so how do we do this? Okay, so step one, we define the function and we plot. Can you copy this one, class? So what the script did is first put a mesh and then a right um, plot and then surf and then shading, okay, with the color hot map so that we have the same figure like previous one. Okay, so basically the equation is this one. Want to mesh and then figure one surf, figure two mesh, figure three surf one with shading and color map. Okay, can you copy this one?
Okay, Doctor.
Sample 4. Okay, do you manage to plot
Yeah,
Yeah,
done.
Doctor.
same figure with the
Yeah, same.
what happened to me? Says that
Yeah,
mesh
I got the same error as well.
line 8 XYZ. Do we have Z? No.
Hmm.
We have F maybe. We should.
Yeah, it's supposed to be F, huh?
Yeah.
We change F, then run. It's okay now. What happened to figure? Figure 1, figure 2, figure 3. I cannot have my figure 3. Still, line 10. Surf 1.
Problem at surf one.
Is there any command surf 1 or just surf? Yeah, there is. Surf 1. So we have to put Z. Why? Cannot have figure 3, eh?
Yeah, me as well.
Problem with figure 3. What does it say about surf 1? Help. Unrecognized surf 1 function. Or I just put surf.
I think just put surf, Doctor.
surf L or surf 1? Maybe surf L. Surf, surf.
If you put only surf,
Yeah?
if you put only surf, because I got the figure 3.
Surf. Kalau surf dapat macam ni.
Dapat color red.
There is another one, surf L. What is surf L? Maybe surf L code. Try. Surf L. I don't know the difference. We have to read what is the difference between surf and surf L. Okay, so let us proceed. So this is the second example where we have two variables. Now the second step after this is to plot to plot your figure and then look at the surfing and the mesh and so forth. And now just like we did previously, first we define our function, and second, either you want to put in file or you can call it in the command window here. Okay, so can you, this is the equation for banana function. Okay, here we put it in our equation function banana, and then we call it. Now we have our x in terms of vector. Okay, and then we define x, the two variable x1 and x2 with the bracket here. Okay, before that, let us, because we're using fmin search. Okay, so let us look at the syntax for fmin search. Okay, find a minimum of okay, hold on. Okay, so this is the syntax for fmin search. So this is your y, your function, and x naught. What is x naught? Starting point. Okay, starting point and attempts to find a local minimizer. Okay, meaning that this one is our starting point. Since y we have 2, because we have 4x1 and x and y. If you can remember our syntax here, F means search. Oh, also I don't have the syntax. Nope, no syntax. Never mind. We go back. Okay, you try this one first, and then we discuss. Oh, it is an example 7.2. In Aurora. So minus 1.2 and 1 is the starting point for x and y. So you can call your function, banana function, either parenthesis or at. Okay. Let us look at the min search. Okay, this is the function of fmin search. Okay, so this is the syntax for fmin search. F eval exit flag and output, or you don't want the exit flag and output, you can just call x and f value. So what it will give us, here, these are the, let Matlab do this. I just want to show you the output, the eval. Where is eval? Yeah, this one. So this is the way it calculates for this function. Okay, so you manage to run the program. Ini I have to close. Banyak lah pula. So I have my function, command C. Oops. New script. Command V. Hopefully I did not miss anything. Okay, save as. Banana fun. Okay. If I don't want to make a script, I just want it call at the command window, put the value there. I define the x, and then I call the function. Okay, so x will be my x, and the output will be my x and eval, and then I call the function fmin search. Command copy and x bracket v. So either I call it like this one, fmin search. I'm using the optimization toolbox, Matlab optimization toolbox fmin search, and this is my function. Make sure my function, oh salah, fun. Okay, and then x, as I described earlier, is my initial point. Okay, you got the same answer with me?
A second.
Hopefully I got it everything okay. And the point is at 1, 1. Oh, figure dah tutup lah pula tadi. Okay. So untuk 4.
Yeah,
Same?
I got the same result.
So what about Izzat?
Mana je tu?
So if you look, suppose the color is not that good. So we cannot find a, for example, if you look at the figure, it clearly show here. I wanted something like this, but I don't know how to define the color. This is actually the minimum point. So is that dapat, where is my answer just now? Oh. Okay, so here. same Izzat. Dapat sama tak?
Ada error
Error.
lah tu. Dekat dekat F4 tadi, dekat comma window
Ni.
tu.
Dekat
Yang
function
dekat
ke
call tu kan?
dekat call?
Kat call tu. F means search tu.
X eval equal to F means search. Banana
Oh.
function X tadi define okey tak?
Oh, I
Define
think
dulu X, the starting point. This is the starting point for X1 dengan X2. X1 start from minus 1.2, X2 start from 1. And then this one, ataupun kalau tak nak, you can put it this way. Put the value pun boleh juga. Minus 1.2 tadi. Minus 1.2. I should have this one. Sama juga. You can put it here if you don't want to define X. Okay, so you got the same answer. Dapat Izzat?
tak dapat ada error.
Error lagi? Function okay?
Error lagi. Function okay.
Function sama
Saya
tak?
takut sebab
Function tu
kita
make sure kalau kat sini panggil banana function, this one, make sure your function you're calling the same function. Nama tu sama, tak boleh tertinggal C ke ada C ke tak ada C ke.
Sebab saya tambah C dekat dua-dua. Tapi dia still error.
So equation pun okay.
Equation
okay tak equation tu? Make sure equation tu okay. Sometimes you
equation
did not get the right answer because of the way you write the equation.
Oh, I think maybe the dot.
Saya besarkan. Because the x1, x is a vector. Kita ada x1 sini. Lepas tu close and open. So you ada double close and then kat sini x2 minus x1 square. And then ada close, open, close. Then square root. Square root, power 2. Okay? Still error, is that? Okay. Plot okay tadi? Tak okay juga?
Okay tak tu? Now okay.
Okay tak?
Now saya dapat value.
Dapat lain?
Okay.
I think the way you write the equation. Nanti check ya?
Yeah.
Okay. Saya habiskan the first part ni and then banyak lagi tak? About 13. Okay. So this is the way you plot and then this is the way you call and this time we use F means search. Okay. Okay, ni another example. Sekejap, let me check my slide. Another example, lepas tu describe this lain tak ada. Okay, so this exercise I let you do this exercise up until half an hour. Boleh? It a bit complicated here. Same sama je, tinggal lagi equation, kena make sure that you put it right. Okay, the exponential is exponential this one. Okay, try Okay. I leave you up until half an hour. Then I come back. I let the slide as
Sorry,
it
what is
is.
this with this transpose? This one is what?
Transpose meaning that if you want it to have, okay.
No, I know the meaning of transpose, but I mean,
Okay,
what's the meaning of this x here?
this one X here,
Yeah, this one.
vector.
Vector. Okay, okay,
Okay,
okay.
okay. So let me pause the record.